friends, what's up in your hizzy? This is Coach Jay from Cyber Day 2016 Monday. Hope you're having a great day today. Hopefully your classes aren't killing you too much. Understand this. I'm going to go through a couple questions off of P.9, maybe help you on the MML. If you have more questions, please email me. And also, I'm also later on going to hit up some questions off the review. The review is definitely not due tomorrow. However, you may want to get started on it so that you're not putting it off to the last minute for your test on Thursday. I will have another one of these. We'll try to figure out a good time for that with the region basketball tournament this week. But again, I hope you're having a great day, and I'll touch base with you tomorrow. All right. Without further ado, let's get started with some problems here. Today we're going to look at some P9 inequalities. Now, for one of the classes, I think I had messed up on one little section, one little part that I got confused on. I don't think it's going to involve in this problem, but it will on a problem like this. I think I did this one in class where if I divided by -9 to get x by itself. Remember, if you divide by a negative number, I said you flipped it, right? And change the bottom. Well, actually, you don't change the bottom. If it's equal, you keep it. All you do is flip it there to where now x is less than or equal to -4. And if I were to graph that, what that would be -4 here, right? We'd have a closed circle, and that would be going towards the left side if x is less than -4. This right here is interval notation. Set builder notation would be the furthest left is -infinity. The furthest right is -4. Note that if it's equal to, it will be a bracket. But if it doesn't have an end, or if it's an open circle, we'll put a parenthesis. That's called set builder. That's called interval notation. And that is how we graph it. Now, with that being said, I want to hit on two of them real quick. And then afterwards, if you need some more help, we'll look at that come tomorrow. I would like for all of the homeworks to be done tomorrow. However, I did make the due date for this homework Tuesday at midnight. So just be leery of that. Now with this, remember, this is just like rational functions with an equal sign. So we're going to treat this just like an equal sign, okay? Where we're trying to get a common denominator. Well, the common denominator, or the CD, is going to be 12, okay? We're going to make that 12. Now because it's 12, we're going to multiply the bottom by 2 as well as the top, right? And within 2 here, it doesn't have a bottom, so we're going to put 12 over 12 there, okay? And this one we don't have to multiply because it's already got 12 there. So what we have, when we distribute the 2, we'll get 8x minus 6. Remember, if this is a negative, make sure you distribute that negative. It's not, but just be careful. 2 times 12 is 24, right? So this is over 12. This one's over 12. And we'll just put equals. We'll bring this back into play here in a second. 2x minus 1 over 12. Well, just like we did before, if there's an equal sign, only if there's an equal sign, are you able to take this out. If this was an addition symbol or subtraction symbol, you cannot take out the denominator only if, number one, it's the same. Number two, it's an equation where we're solving for x where there's an equal sign here. So we're going to multiply by 12 on all three of these to where when I do, and the reason why I can do that is because what I do to one side, I can do to the other. So really, you could just take out the denominators if they're all the same. So now we're left with 8x minus 6 plus 24 equals 2x minus 1. I'm going to subtract 2x on both sides, leaving me with 6x. And I'm going to add this here. We'll make that plus 18 equals -1. And that's where I can kind of subtract 18 here. Subtract 18 to where we get 6x is equal to -19. Okay? -19. Now, my last part is when I solve for this, I got to divide by 6. Since I divide by a positive number, I keep what was ever up top here the same. So x is greater than or equal to -19 over 6. And that right there is what I will keep for interval notation. Now in set builder notation, let's first graph this where we'll put 0 here. -19 over 6, if you plugged in your calculator, it would be like -3 point something. So like this, it would be like right in here, right? And it will be a closed circle because it's equal to. And if x is greater than or equal to, if it's greater than, I always think of this as a arrow that points this way as long as x is here. If x is greater than, it's going to go towards the right, where this is negative 3 point whatever, negative 19 over 6. So that's kind of where we're at. That's kind of how we graph it there. Now, as far as set builder notation, the furthest left we're going to go is negative 19 over 6, and it's equal to, so we're going to put a bracket, comma, what's the furthest right? Well, the furthest right is infinity, and because it's going to infinity, we'll put a parenthesis. So we have both interval notation, set builder notation, and then obviously we graphed it as well, okay? Now look at this one. This one's different. This acts as almost like two equal signs here. But same thing holds true. If I were to add one, and we start in the middle, by the way. Start in the middle. Okay, so if I add one, I'm going to have to add one to all of the parts there to where this cancels, leaving me with 2x, and I'll put 2 equals here. We'll have negative 10 here as well as negative 4. Now, if I were to divide by a negative number, okay, again, I divide by the middle. I continue in the middle to isolate x. Remember that if I divided by a negative, these would flip-flop, right? Again, the underneath would not change, but it would change where it would head there if it divided by a negative number. So now I've got negative 5 as well as negative 2. And I'll bring these down to where now x is greater than negative 5, where it's kind of less than or equal to negative 2. Okay? So if I were to graph this, and again, this is interval notation. So we'll put 0, 1, 2, negative 2 here, 3, 4, 5. We're going to put 5 here, negative 5. Now think about this. What we're going to do at negative 5 is going to have an open circle, where at negative 2, we're going to have a closed circle. Now in graphing this, if x is greater than negative 5, that means that if you think about that, greater than would be to the right of it. But it also says x is less than or equal to negative 2. So where x is greater than negative 5, x is also less than negative 2. So the only part between that will go is we're just going to highlight in between negative 2 and 5, leading up to negative 5, but not on negative 5. So the furthest left of this is negative 5, where the furthest right is negative 2. Negative 5 is a parenthesis because it's open, whereas negative 2 is a closed circle. So we're going to put a bracket there. So this is set builder notation, and this is interval notation. Okay? Awesome. I hope that was helpful for you. All right, let's do this. Let's go to some of the review questions. I think that will be helpful. All right. Let's think here. What are some of the more rough ones? First of all, if you notice on the bottom, 34, 35, 36 are review. Those will be on the test. Let me repeat that. 34, 35, 36 will be on the test, and you need to study those, okay? Numbers 26 to 33 are off of P.9. Those are ones that you really want to look at. Maybe even today, maybe that's a good goal to have numbers 26 to 36 done by tomorrow for the review. Might be a good idea there. But again, that one is one that you might want to look at as well. What I'm going to do now is I'm going to start at number 25 because I feel like those other ones I may have questions on. But the ones that we're going to look at right now are numbers 25 through 1. And what I want to do is start from the 25 and work our way backwards. So if I were to look at, let's say, number 25, 9x squared minus 30x, 9x squared minus 30x plus 25 equals 0. The question is how many solutions? Okay? Now remember, anytime I ask for how many solutions, we have our gangster name of discriminant. Okay? All right, remember our gangster name. Remember discriminant, all that tells me is it's b squared minus 4ac, which if you remember, that is within the square root of our quadratic formula. There are 3 total options you can have. Number 1, it could be positive. Number 2, it could be negative. Number 3, it could equal 0. If it is negative, anything inside a square root that is negative as a result will get me no real solutions. That's very important. Now, if you were to do the quadratic formula and you were to get a negative number, continue. That's okay. But if I asked how many solutions there were and you got a negative number, you could stop right there and tell me no real solutions. Now, if it is 0, Remember, this is plus or minus square root of b squared minus 4ac. If I added 0 or subtracted 0, you would still get the same thing. So that's why we have one real solution if it is equal to 0. And then finally, if it's positive, you guessed it, we're going to get two real solutions because we'll have one that's plus or added and one that's subtracted. And that's kind of what we do when we go from there. All right, now, the important thing to note, A is 9, B is negative 30, C is 25. Make sure you take that negative with a 30. So what we have is b squared minus 4ac, where b will be negative 30. Make sure you put that in parentheses, okay? We got a lot of mess ups on that on the quiz. A will be 9, C will be 25. Now, as I work inside, negative 30 squared, 30 times 30 is 900. Again, it's positive because whether this is positive or negative, it's squared, therefore it's going to produce a positive out. Now, my next part is what is negative 4 times 9 times 25? Well, when you put that in your calculator, or you could say 4 times 25 is 100 times 9 is 900, we know it's going to be 900 out. Now, since there's only an odd number of negatives here, when we multiply, we're going to put a subtraction sign there. If, let's say, this had a negative, this would be positive, but it doesn't. So we're going to keep it as is. So 900 minus 900 is 0. So how many real solutions do I have? I come over here and I notice that one real solution is what we would have if that b squared minus 4ac was 0. Okay? All right. Hopefully you got that one there. The next one is probably, if I were to say, probably the trickiest one on this test here. It's just tough. It's this one. Okay? And I think it is number 23. 23 here. I'm going to do it right down below. Now, the objective of this is to solve for P. Now, the struggle with solving for P is because there's two of them. If you looked at the previous one, 22, many of you could probably do that one. But in this one, because there's two, that becomes the struggle. The easiest thing to do is put PT underneath A and underneath P as if I divvied it out now into two fractions. So we're going to say T equals A over PT minus P over PT. Now, you'll notice that since there's two P's here, okay, because I put it over it there, I'm just going to cancel them out to where it's 1 over T. So if it's A over PT minus 1 over T, we want P by itself, so we're going to add 1 over T to both sides, okay? This kind of seems weird here, 1 over T. So what I have now, I'm going to put this right here. I should have probably erased it, but that's okay. We'll do T over 1 plus T equals A over PT. Now, I could try to get a common denominator, but right now I'm not going to really worry about that. What I'm interested in is trying to get this P out of the bottom. So like anything, I'm going to multiply by PT on both sides because when I do, I note that it cancels out there. So what I have now is A equals PT times T plus 1 over T. Now, since the T is being distributed across, what I'm going to do is I'm going to leave the P outside because I want it by itself, and we're going to get to that in a second. But I'm going to distribute the T to where inside it would be T squared plus, and what's T over T? Again, if I did that, it would cancel, leaving me with T squared plus 1 with a P on the outside equals A. Well, now, how can I get P by itself? Well, these two things are multiplied. Remember, this x is 1, this x is 1. They're being multiplied. So I'm going to divide by T squared plus 1 on both sides. To where when we solve for it, these would cancel, leaving me with A over T squared plus 1. And that's what P would be equal to within that problem. I anticipate that we'll have to go over that one more time, but that's one to come back to if you have any questions regarding how do I solve for ones that want me to isolate the variables there. Alrighty. Number 21 we did on the quiz. Let's see. Let's come up with a game plan here. I want to do 15 is very similar to 21. 14 is very similar to both of those. I'm going to do number 17. let's do 17 and 18. 17, 18. 6, 17, and 18. How about that? 6, 17, and 18. And what I'm going to do, I'm actually going to do this. Let's go. Let's do this. 6. I'm going to copy these bad boys out, and we're going to take a look at those. And again, I'm looking at the review here. Note the review is online there, right below. I think even this podcast right here. So you can check that out. 6, 17, and 18. So I'm going to come there. Let's see these screenshots. Where are you? Not that one. You all wouldn't appreciate that one. That would have been hard right there. All right, let's see here. Still not there. Where are you? Ah, there you are. There's one. And is this the second one? Perfect. Perfect, perfect. All right, we're going to take these two right here. Awesome. All right, so these three are ones that, man, I think that we probably just need to go over a little bit, okay? We'll do 17 and 18 first, and we'll finish off with 6 there, okay? And I'm going to pretend like 6 is plus, but as I look at this, actually, I'm going to look at this a little bit closer. 6 is, I think that 6 is dividing, so I'm going to actually take number 9 here. Number 9, it looks like a 9's a little bit tougher. So we're going to take that one. Yeah, there we go. So actually, we'll talk over both those, but I'll really focus on 9 because I feel like that's the one we struggle with most. All right. All right, let's do this. Now, on the top here, notice that it's already in factored form. Now, that's pretty nice for us, but the problem is that it's equal to 5. Now, normally that's equal to 0, and so a lot of times when I get it to this point, I set them both equal to 0 and solve. But I cannot, in this case, since it's equal to 5, set both of these equal to 5 and solve. So I've got to do it differently. So I've got to first distribute this on this side to get it out, and then I'm going to subtract 5 to both sides. So 3x times x is 3x squared. 3x times negative 3 is negative 9x. 5 times x is 5x, and 5 times negative 5 is negative 15 equals 5. Now, this is where I could subtract 5 to get it equal to 0. That's really important. To where now I get 3x squared minus 4x minus 20 equals 0. Now, I could do this in a number of different ways. And as I think through it, there's again, multiple ways that I could approach this. I could try to factor it. In fact, I always try to factor it. But in any scenario like this, we could also go to the quadratic formula as well. Whatever floats your boat is completely up to you. For me, I want to go to factoring. Let's just see if we could factor. So we could do the A times C method or the check and guess. A times C is negative 60. Okay, so my question is what number when remember A times C, by the way. A's here, C's here, B's here, right? Make sure you take the sign with it. So that's how we got negative 60. 3 times negative 20. So two numbers when multiplied get me negative 60, but when added get me negative 4. Now, this is where it becomes very, very difficult to kind of look at because you could kind of take this a bunch of different ways. You could take like 12 and 5 with one of them being negative, but either way, you won't get a combination of negative 4. You could take 15 and 4, but one of them negative still doesn't work. But then you look at 6 and 10 with one being negative. You'll notice that negative 10 times 6 is negative 60, but when added, get me negative 4. So I'm going to put negative 10 and 6 here, and we're going to put 3x next to both here. Now, my question is can I take anything out of both of these? I can't take anything here, but I can take a 3 out here, leaving me with x plus 2. Remember, I have to take it out of both, times 3x minus 10, and I notice that right there would be my factored form. Since it's equal to 0, I can now set, because it wasn't equal to 0 up here, I couldn't set these equal, right? But because it is equal to 0 now, I could set both of these equal to 0 and solve. So I can subtract 2. So x is equal to negative 2 as my first answer. And add 10, divide by 3. x would be equal to 10/3 as well. Remember that in a quadratic, if I were to go this way, right, what it means is that at -2 and at 10/3, that is where it's going to cross the x-axis. So those you call them x-intercepts if you want to, but that is what we're looking at. That's what x is equal to there. And that's how we solve. All right. Remember with dividing, just a quick hint, make sure that you factor out first. After you factor, make sure you flip right side, or you could say find reciprocal of right side is fine. And then make sure you cancel out top and bottom. Make sure you also tell me restrictions as well. Okay, let's do the addition one. With the addition one, oh no, by the way, up here on number 18, I forgot to do that one. This one you would do quadratic. Okay, quadratic. I will look at that one at the very end. Okay, we'll look at that one at the very end. Now with addition, same thing. We want to make sure we factor out. Okay, so again, right now I'm kind of just factoring out here, x minus 3, x minus 2. So we have it there. Now, the CD that we're trying to look for, what we're trying to make everything over top of is x plus 3, x minus 3, and x minus 2. Because again, you kind of take one of each, and if it's shared, we only take one. If it has an exponent, then we take the highest exponent in the CD there. So my question is what is this missing that this has? And we know it's going to be an x plus 3. So we're going to put that there. What about this one? Well, we know it'd be x minus 2. So we're going to put that there as well. So now on the top, I'm going to distribute x times x and x times -2 to get x squared minus 2x on the top. And I'm going to put it here. It's going to eventually be up in this area. Now, x minus 1 times x minus or x plus 3 is where I distribute. So x times x gets me x squared. X times 3 gets me 3x. Now I've got to do it to -1 though. -1 times x is -x, and -1 times 3 is -3. Now when combining, I now could say 2x squared because I combine on the top, right? -2x plus 3x minus x would be, I think it's 0x. So we just say 0, right? We don't even have to say it. And then minus 3 because that -3 is by itself. So my answer would be 2x squared minus 3 all over x plus 3x minus 3x minus 2, where x cannot be equal to -3, 3, and 2. And remember over here, when we come to dividing, whether we cancel out or not, still make sure you say it's a restriction on that problem. All right, last but not least, quadratic. We're going to do the quad solve here. So we'll do x equals -b plus or minus the square root b squared minus 4ac all over. I hear you singing right now. I don't care if people think you're weird. Keep singing, all right? So now x equals -b, which is -7, okay, plus or minus the square root. B squared is -7 squared minus 4. A is 3. C is 1. Make sure you take the signs with it, and make sure you put that one in parentheses. And 2 times A is 3, and so we have that there. So now we change this to a positive. So now we have 7 plus or minus the square root, and we know that's 6 on the bottom. -7 squared is 49. -4 times 3 times 1, or we'd say 4 times 3 is 12. With a negative would be -12. And when I subtract, we would get the square root of 37, which I don't think I can simplify. So you could either keep it as is, or you could say 7, 6 plus or minus the square root of 37 all over 6. Either of those answers will work for the test on Thursday. All right. Hey, I hope this was helpful for you. I know it was a little bit longer than probably what you were expecting, but I think that it will be beneficial as we move forward to look into that, and also as we study for the test Thursday. Hey, care about you all a lot. Have a great day. We'll see you all later. Bye now.